Good afternoon, everyone. My name is Xuan Liu, a PhD student from USC. Today, I'm going to talk about our recent study, a test-retest study of single and multiple delay pCASL for choroid plexus perfusion imaging in healthy subjects aged from 19 to 87 years old. I have nothing to disclose. The choroid plexus, which is mainly located in the lateral ventricle, is like the brain's cleaning and delivery system. It makes the CSF that surround our brain and spinal cord, carries important nutrients to brain cells, and helps to remove the waste products. When the CHP isn't working properly, it's connected to the serious brain disease like Alzheimer's or even depression. That's why the scientists are so interested in studying that. But here is a problem. The choroid plexus is very small and it has lots of tiny blood vessels, making it extremely difficult to examine with regular brain scans. This is where ASL, a non-invasive perfusion MRI technique, offers new opportunities. ASL can show how blood is moving through the brain. Single delay ASL is widely used for its simplicity, but it assumes a fixed arterial transit time ATT, which may lead to inaccuracies. In contrast, multi-delay ASL capture perfusions at different time points, enable more precise CBF and ATT, particularly valuable for the choroid plexus. In this study, our goal is to perform a comprehensive and quantitative comparison between single delay and multiple delay ASL of the choroid plexus. Additionally, we evaluate the performance of single delay method when ATT is longer than PLD. To achieve this, we separate it into single multiple delay comparison as well as a perfusion measurement for choroid plexus. We designed a MRI experiment using a 3T Siemens scanner with a 32-channel high coil. The study involved 28 healthy subjects, 40 males and 40 females. Imaging parameter settings are resolution of 2.5 by 2.5 by 3 mm isotropic, 40 slices, and the labeling duration of 1.8 seconds. The single PLD was set at 2 seconds, and the 5 PLD are 0.5, 1.5, 2, and 2.5 seconds. This is a test-retest scan experiment where the single delay was used a single compartment model, and the multiple delay applied both weighted delay and the model fitting approach for reconstruction. Then we manually segment the choroid plexus ROI. Based on the developed models, we calculate the ICC for each measurement in the choroid plexus, gray matter, and white matter. Then we evaluate the relationship between each and the lots of parameters, including choroid plexus CBF, ATT, volume, and blood flow. Here we show the test-retest results and ICC for choroid plexus using single and multiple delay. The result shows that both methods has excellent repeatability for the choroid plexus and gray matter. The ICC of multiple delay is slightly better than the single delay. The reliability of ATT estimated in the gray matter is higher compared with CHP and white matter. Then we compare two different methods, weighted delay and model fitting, for the 5 delay PLD. In general, model fitting shows better repeatability and accuracy than weighted delay on CBF and ATT for all regions, especially for white matter. In this case, we will use model fitting for the choroid plexus analysis later. This table summarizes test-retest mean CBF and ATT values and their ICCs in choroid plexus, gray matter, and white matter, consistent with the findings in the previous figure. This table shows that the model fitting approach yields ATT values around 10% longer than those from weighted delay approach in white matter, with slightly longer values observed in choroid plexus and gray matter. Here we present one slice of CBF and AAT map from 50-year-old male subjects from both test and retest scans. Figure A and C display the test and retest CBF maps, while B and D present ATT maps obtained using model fitting and weighted delay methods from test and retest scans. The zoomed-in panel shows choroid plexus perfusion and ATT overlaid on T1 images. All methods demonstrate relatively robust results in both test and retest scans. Both single and multiple delay can show that good structure of the choroid plexus. This figure presents ATT histograms for all voxels in choroid plexus, gray matter, and white matter using model fitting approach. Around 12% of the choroid plexus voxels and 15% of the white matter voxels exhibit ATT values longer than 2 seconds. Prolonged ATT can lead to significant underestimation of CBF when PLD is shorter than ATT in single delay ASL. We also examined the relationship between CHP perfusion, ATT, and age through the scatter plot with fitted linear models. The analysis shows that CBF values in CHP has a significant negative correlation with advancing age. In contrast, ATT displayed a positive association with age, though it didn't reach the significant. When comparing perfusion across different regions, we find the consistent positive trend between age and ATT in gray matter, white matter, and CHP. However, the age-related decline in CBF was only shown in choroid plexus, and the gray matter and white matter show slightly changes in CBF with increasing age. Finally, our evaluation of structure and functional changes demonstrate that significant positive linear relationship between choroid plexus volume and age. In contrast, total CHP blood flow shows a non-significant increase with advancing age. Here are some take-home points. Test-Retest reliability of CHP-CBF measurement was excellent. CHP volume increases with age. CBF declines with age, aligned with literature, and total blood flow did not show the significant age-related changes. Single delay ASL may underestimate CBF, particularly in the regions with long ADD. In conclusion, multi-delay ASL provides high accuracy and reliability. It is recommended for the quantification, especially in aging groups. Thank you so much for watching.